What's up? Okay. Today we're going to be working on the render loop for tamagotchi.nvim. Again, I'm going to be trying to just jippity what I can. It kind of worked last time. I know it's very hit or miss, but I think, at least in the case of writing Lua, there's not a lot going on. I find that jippity, a lot of times it has problems keeping up with the amount of types across a large project, which is really not a big of a problem here. And I'm kind of doing like a TDD approach, which I wouldn't do personally, but I think it works for this case of just trying to get GPT to just write everything. so, so yeah. Current state is quite elementary. You can see the age increasing over time, but really the age and the sprite should both be changing constantly while this window is open. So let's implement that. Okay, so let's look in window Lua. So refresh timer, I like that. Initial nil. Okay, so ASCII bar, that exists. So a little bit different here in build UI lines. Let's start by just reading. Sprite, between multi-line, name, age, satiety, mood, bar. So break the sprite into lines. Okay. So I agree with that. Break sprite into lines if applicable. That involves sprite text. So it's guaranteed to be the empty string based on that, so you don't need to have this part. Sprite lines for line up to, yeah, so that looks solid. For line and sprite text up to gmatch iterator function that turns the pattern. So I'm gonna just trust that. If I'm just trusting that, it should be quite easy to see if it works or not in a second. So build the right div. Age, name, attributes. Okay, so that's rather nice. Ooh, that's a nice syntax. I like this string literal colon format as like an instance of the string table. I believe that's what you would say there. That's rather nice. Only gripe is that I just prefer to inline this from the start. Sprite might have n lines. The right column has at least 4 lines, so we're getting the lines count. That's solid. Define left width as half of the total width. I agree. And then for the lines, so you must print it across the lines. So you're gonna go here, P format. For I equals 1, lines count. Left stir, sprite lines of I or blank, and then large stir should have a similar thing. And then combine, return final lines. Is that? So yeah, padding the sprite line on the right. Yeah, with spaces to maintain the left width if the sprite line is wider. So truncate. And that's sub 1 string rep. I think that looks solid. My first intuition. Let's move on and we can determine it in the test. Rates if footing window entire width is used, so we do a left right split set for text. Address these calculations. It's using the entire width. I don't agree with that. Yeah, I don't agree with that. I think that's misguided. So we're not going to do that. It does need to be set modifiable. So these are now deprecated. Problem is for what? Dep. So it's deprecated with no comment as to what. Change it to, is it set var now? Could it just be set var now? NVIM set option deprecated. Set option. Set option value. Okay. I'm just assume the behavior is the same. Win-win. Width, height. Okay. So we've opened the same paint once. You want to start the refresh loop. So that's replacing update, it appears. So I don't think update is defined anymore. Update UI is. Where's it called? Here, okay. It resets the height and width as well. We're adding that to update. Yeah, okay. So lines, pet width. Is that right? Did I skim that for width with window height? Yeah, I think that's fine. Okay. So open sets the timer loop, refresh loop. Agreed. Update UI. Skew me. Lines, false lines, pet with height. Agreed. So close. Stop the timer if it's running is the new appendage. Agreed. Looks good. Update UI, we've already modified. Toggle should be unchanged, I believe. Indeed. And now we have a new function. So function m.start refresh loop should take nothing. It is local to a pet. Good point. So if refresh timer, stop it. So this is starting it. So if there is one, delete it. Okay. Vim loop new timer. So this looks like second updates. So get a new timer. So I don't know this new timer function. So let's spec that. Creates and initializes a new UV timer T. Returns the user data wrapping. Good enough for me. Timer start. Integer. So that's the timeout. The repeat. So this is millisecond wise. Repeat interval in milliseconds. So this should be more like 10 FPS, sure. Time out in milliseconds. Yeah, okay. And then degrade. That's not how that works. So to do untrivialize this. Refresh UI, it's still open. So close. Stop timer. So we have a thing, Windows set option value and no value. Vim win set option value. So that was supposed to be not a thing. Okay, let's reinspect that. So let's just use the deprecated function and just see what happens. So the age is actually kind of good. So it looks like trash, but it works largely. Okay, so that doesn't look horrible. Okay. So it actually doesn't look that bad. This is like where I'm trying to go. So I think hmm. So this should be 0. That should be 0. Okay. Solid. Okay. Kind of freaks out if you start doing macros. But in general, I think that's good. So we need to update the test to have a new function update. Is it not update UI? Function hat update. Okay, yeah, so that sets that. So that's pretty solid. Pretty good so far. Next, update a bit. Oh. Check. So there should be more logic to it. There shouldn't be every pick. All right. Okay, so let's see what it has to say here. The decrement chance is a solid tactic. Yeah, I like that. I like that. Enough. So where's increased mood used? What is the point of this? So it should be more like a 1% chance to increase each attribute every tick, right? Perhaps a 10% chance because I still want to be able to see it because I kind of forgot it's behind the scenes. It's out of 100, but there's only 10 visible states. Is it really that easy? Knit Lua? Is it really that easy? I don't think it was that easy. So I think it is pretty good at writing tests like this. At attribute increase. So before each function, satiety 80, mood 50. Should increase mood 10. What's the point of that? See, these functions just don't exist. What's the point of those functions? I don't see it. Or is it called here? Increase mood 5. Yeah, okay, I see it now. Hat. There we can add these back. We saw it there, so let's nvim it. So Mood had bad RNG in the beginning, it appears. So Tidy keeps getting updated because I think this is technically writing to the buffer. So Mood is at... So if I save a buffer a bunch of times in TG, okay. So I just saved a buffer a bunch of times. Let's go back to here. Or we want to go to update. Or we want to go to init and see when they're incremented. So if a buff right posted, that's hitting Mood by 5. Text changed. Text changed is kind of flawed because updating the window triggers a text. There's nothing else called load. I thought there was a pet function called load. And what's the difference in the dot? I don't know if I was mixing that up. Pet persistence should return no if no save file exists. That's curious. Why does it work with a dot? Maybe because the function just doesn't exist in that case. Passed in. Got an anonymous pet. Expected no. That's pet persistence spec. 45. It should return anonymous. Yeah, I think it should return the anonymous pet. Assert R equal the anonymous. How do I get the anonymous pet, dude? So it's 3 seconds old, Q, and then so it resets. Loaded pet and no value. Loaded pet is now 145. Using a dictionary as a string. $45. Loaded pet is a no value. Yeah, it should be no. Would there be an equal sign? Well, while that's going, let me empty my But we need to get a hole in the bottoms. Making a hole in a glass bottle with and without a drill. That is so specific. No drill, brother. Using a pickle? I'll probably try to do this with a stick. See how that works out for me. It's gonna take a lot of force. Like a dangerous enough force or something, and something with your hand. Cursor moved. Oh, okay, that's kind of smart. Let's go to a knit Lua. Starter Taylor doesn't know that. Wow, that's so AIDS. That's so AIDS every time you move the cursor. Oh my god, that's so AIDS. Every time you move anything, it just breaks. Alright, we're just changing the... Okay, this has gotta go. This has gotta go. This has gotta go. V to 0. Yes, I know. EC. Oh my god, that's annoying. Okay. Now I can actually move though, which is nice. Okay, so now if we go here, it's because you're calling a no value. Okay. Back to init. Do I need to import something? Config window. Be seconds old. So it's an anonymous pet. Why is it an anonymous pet? Hmm. Oh my gosh, my options are up 100% today. It's insane. All right, I'm gonna put some chicken in the air fryer. You know what I mean? Ja, специал. Какая погода сегодня? 52 градусов по Фahrenheit. You should take the machine. So I'm gonna do my vacuum chore right quick. Nami. Hello, Doodlebot. Doodlebot. You know what I'm finna doodle bob? Doodlebot. Wait, no, and erase this. Alright, so did some vacuuming, some other things. You can check that off on my calendar. I mean, did this, did this. Ladna. So I think what I'm gonna do, I have 10 minutes for my things done. I'm gonna a little bit more programming. Then I'll watch a Lua video and leave to go work on compilers. So what's the most recent thing I did? That's undefined. So what was I doing? So this buffer's open. What's the one I'm in right now? This buffer's open. So I don't really remember what the last thing I changed was. Test pass, hopefully. There we go. And that tamagotchi. So it persists on open, but not here. It says anonymous pet. Okay. So let's look at a init. So what does pet.load do? Just gotta wait for the workspace to load. File path or here. So no file path. So by default going to tamagotchi.json. The default pet values defaults desired name is the values default pet. I don't even think that exists. I think that's just nil. So the default pet name, config values. So that means I need to go into my Lua config. Or better, I need to go to config defaults, go here, default pet. So you go to Tamagotchi. So now, this is anonymous pet. Okay, so if I go here, hopefully I didn't just freaking dox myself. Okay, good. Then we go to Tamagotchi. So require setup default pet is equal to Tamagotchi. Looks good to me. Anonymous pet still. So why is that the case? Because default pet Tamagotchi. Back to insert. Loaded pet, pet.load. So if we go to pet, we go to load. Lua functions colon versus dot. Self as a parameter is colon. So no, it should be a dot. It should definitely be a dot. Save. Doesn't even need self, it should be a dot. Pet persistent spec. Pet dot load. New. Save. Dot save. Dot save. So here we have attempt to index global self. Where's that? In Pet Lua 130. Oh, we do need that. Okay. Still anonymous pet. Okay, so let's go back to yeah. So do pet load. Pet data tamagotchi JSON. Loaded pet, it's gonna be the loaded pet. Nvim plugin Lua debugging. So how do I just print? Printf. So let's see print. See if we can just print vim.inspect loaded pet. See what happens. So it's loaded the anonymous pet. Okay. So it's explicitly loading the anonymous pet. It's interesting. What if we just print? It is an existing table. So the load function is loading something. It's loading the anonymous pet. So where's anonymous pet? That's when you don't specify a name. Pet new data. Equal JSON don't code content. Uncode is lines. Lines is the file. So let's print lines here. No, that didn't really do what I wanted. Print vim.inspect. Birth time anonymous pet 80. So print it twice. So I need to clear that. So tamagotchi.json. I think it's because of the cache. Um, Standard path data. Where does Vim standard path point to? So let me just try to traverse my DIRs real quick. OS session A cd.nvim OS. No. cd.config. Hmm. So I figured out how to clear the cache, but it didn't work. Still acting like there's an anonymous.
You're here to learn about Lua, so let's just go ahead and get started. We're going to cover all the basic syntax. We're going to cover comments. We're going to cover all the primary types of variables that you're going to use inside of Lua, how to define them, and how to use them. We're going to talk about control flow. We'll talk a little bit about modules, then we'll talk about some more advanced function features, following up with some metatables, and then a little bit of bonus for those of you who make it to the end of the video. Before we do that, though, we need to get a little bit of background sorted out. Lua is elegant. It's a beautiful language, and if you think it's not because it has one-based indexing, I've got a video for you in the description. But that's not what we're going to talk about today. Lua, a primary idea inside of it is mechanisms over policies, which means that instead of having special keywords for things like classes, Lua allows you to use its simple building blocks to compose more complicated ideas. So Lua gives you the mechanisms to implement them instead of special keywords or special things built into the language. What's beautiful about this is that lets us explain all of the practical things you need to know to get started with Lua in one video. It's very easy to pick up and very easy to get started. It's also designed to be embedded. In this case right here, you're actually going to see me inside of my NeoVim program execute Lua live and see the results. It's embedded inside of NeoVim. You might also be here because you want to know because you're modding in WoW or something like that. I don't know. Lua's embedded in a bunch of different places, and I just think it's really cool. I think it really executes well on its design principles and really targets those. It knows how to say no, which is very important for a language, C++. Anyways, first thing, comments. They're really simple. They start with a dash dash. This is a comment. It ends at the end of the line. You want to do multi-line comments? You got to do dash dash, and then these little bracket guys. We're going to see them again in a moment. Simple literals look like this. Numbers, just type the number, guys. I don't think you really need me to tell you this, but basically you can sort of think of this as local. It says, hey, don't make this a global variable. And then this establishes a new name within the current scope. Then you've got number equals 5, okay, right? So that sets the number equal to 5. We have strings with double quotes, with single quotes, and once again, we got the little double bracket guys. And once again, this makes something that was before a single line kind of construct into something that can stretch over multiple lines. We've got Booleans, truth is true and lies is false. You can set multiple values in one line like this. We're going to be returning there later. And last but not least, well, actually last and least is nothing, or the nil value, right? So it's nil. And you can use that as a proper value. And there's a few tricks with that later, but we'll come back to that too. Functions are first class in Lua, which pretty much just means, hey, you can make them as values, right? There's two primary ways we define them. One is like this, where we say local function, name of the function, and then any arguments. Inside we have the body, and then it ends with end. Lua doesn't use a lot of brackets for denoting scope. It usually uses words. I think it's kind of pretty. I really think you won't notice it after you write it for a little while. The other way that you can define functions is doing something like this, local greet. And then since functions can be values, this section right here defines a new value of a function and assigns it to greet, just like we did for these other simple values here. In this example, we've got a higher order function, which is just a function that returns another function. And in this case, this function takes in a value, and then we use that in our sum that we're going to do later. So in this case, we have add 1. We sort of get that value from this higher order 1, right? Which binds value right here. Those are called up values. You don't need to know about that today. You can just think about, it saves off that value. So if we execute this, we'll see that the output is add 1 of 2. That's 3. Okay, hopefully you're following along, right? Hopefully that part wasn't too crazy. Okay, and so that's sort of the output of doing that. In Lua, we basically only have one way to store data, and that's tables. Tables are like lists where you can have, a sequential index of values and you can iterate over them and store them. But they're also like maps or dictionaries from Python land where you can store different things inside their keys and map from one value to another. So the first thing is we can use tables like a list. So this is like we have the first value is first, and then 2, and then false, and then a function. Lua's lists can be heterogeneous, right? They can have different values. Lua doesn't care. It'll put all of them in a list for you. So if we get the first value, yes, you heard me right, the first value, we're going to get first. Hey. Nice, right? Nice. That's what you'd expect, is because first is the first thing. Anyways, so now we get fourth is 4, and we print this value. And we call this function before we do, so it prints right here. But that's beside the point, right? So we get a function out of the fourth spot. So that's tables as lists, but we also have tables as maps. There's a few different ways you can write values here. You can do a literal key. This basically just translates to the same thing as if you did a string here, except if it doesn't have special characters like spaces or like pluses or ats or all this other stuff, you can just write it without the additional quotes and then sets it equal to a value. The other thing you can do is inside of brackets right here like this, you can put any expression you want, and then that's a key, and then you can set a value to here. Well, you can even do functions. Now, pause here and think, what is going to get printed here? So this one, probably you can guess t.literal key, right? That's kind of the same thing as indexing with a string. What do you think is going to get printed for this last one? Pause. Right. Okay, and now execute, and you'll see nothing. Nothing gets printed here because this function is a different function than this. Lua doesn't know what's inside of the functions, right? It's just sort of like by not just like whether they're referentially transferable. It doesn't really matter, right? These two different things are two different functions because we made them two different times. So they're like different pointers. It's not a huge deal right now, but it's just something I wanted to point out because it might be confusing if you expected those to be the same because they're the same function. No, they point to different Lua functions. It's okay. If you don't get it, just skip that part. We are not going to cover threads and user data, mostly because you're not going to encounter these that often. Threads are from the coroutine library in Lua, which is a very cool cooperative sort of scheduling thing that you can do, but most of the time you're not going to run into those, or at least not directly. And user data is when you have some C library that's going to interact with Lua, and you probably won't interact with that at the beginning either, but those are the only other two types of variables that we didn't cover. So control flow. The first kind of for loop we have here is if we have something like a list of something, we want to iterate over those items. We can say for, and then we have a variable equals, and then this is start and stop. this hashtag favorite accounts isn't actually a hashtag.
How
That's an
of a
operator,
magma
and it
move?
is the length operator. So it gets the length of 1, 2, 3. And so when we run this, we'll see 1, 2, 3, right? That's the index, 1, 2, 3. And then we can index into our list to print out those values of TGV, the prime and terminal.shop, by the way. The other way that we can do this is we can use what's called I pairs, right? And this is sort of like in index pairs, the iterative pairs here, right? And this returns two values, the index and the value at that index. Notice how in this version, we didn't have to sort of index back into the array. This just returns it directly. And those two things are basically the same. But what's going to happen here? What's going to happen here if we try and do the same idea over a map? It's not going to do anything. That's because this length operator for tables operates on sort of the idea of I can only give you the length of an array that's or of a table that acts like an array, right? So I'm looking for sequential things that aren't nil. So when we execute this, literally nothing's going to happen because this is essentially saying for index equals 1 to 0. Okay, well, I'm done. Skip to the end. We need a new function to help us out here. That function is pairs. So I pairs is, I like to think of it in my head, integer pairs, because it's the integer numbers that we have. And then pairs is just for all the values. So if we print this off, we'll see that, hey, the reading scores for THDV is 9.5. That's the key in value. And for the primogen, it's not applicable. Notice that we can store different values in the values itself, different types of things. It doesn't matter that this one's a number, this one's a string. Lua doesn't care about that. Next thing, if. So in this case, it's very similar to how you're probably expecting most ifs things to work in languages. The only thing is there's no like parentheses required around here, and there's no curly braces. So you just write if, loves coffee, then you should check out SSH terminal.shop. It's cool. Else, they should still check out SSH terminal.shop. It's still cool. So if we execute this, we'll see those values here. And the only thing to note here that we haven't talked about yet is the only falsy values are nil and false. Everything else is true. So 0, empty table, a function with no return, whatever, it doesn't matter. Only nil and false are the false values. Everything else will sort of evaluate to a truthy value and go down this path. So that's for if statements. There's also else if. You can figure that out. I know you if you're this far in the video, you can figure out how to do else if. Anyways, modules. This is once again, we're going back to this idea of mechanisms over policies. Lua doesn't have a special thing that's magical about a particular block of code to make it a module. Instead, files are just big Lua functions effectively. And so if I had a file like foo.lua, you might see it start off with something like local m equals a table. That capital M, once again, nothing magic. It's just kind of a convention that people use to stand for module. So I can set values on my table just the same way that we were doing earlier and return that. We don't have to return a table. It's just usually good to return a table because you might want to add other functions later or do other things like that. So it gives you a little bit more flexibility. But if we're in another file, bar.lua, and assuming foo is like on a runtime path and all this other stuff, we can do local foo is require foo. This name could be anything we want. Usually it's good to name it a name that sort of reflects the thing that you're importing here or requiring. And then you can call foo.coolFunction, right, which was defined on this original table. So modules are just basically the result of whatever's returned from a file. If we remove this return here, then this would break because nothing gets returned from the file. So that's like returning nil. Okay, a few more things about functions. Functions can have multiple return values, which means in this case, this one returns 4 values, 1, 2, 3, 4. And when we sort of receive those values or try and place them into something, we get first, second, last in this case. So what's going to happen here is the first value gets put in, so that's this one, that goes here, second goes here, third goes here, into last, and we discard any additional values. If you have something here, basically Lua is going to let you unpack those values until it notices something that's going to take its place. Now, that probably doesn't make any sense, but let's give an example here. This function takes a variable amount of arguments, which is denoted by a nice ellipsis, or ellipse, I guess is sort of the single ellipse. I actually don't remember. And you can place this inside of some table like this to put all of the values inside. So this is going to say, hey, take all of the things that you put right here, right? It's like you're literally replacing the text. So take all the arguments that you passed here, put them here. So it's like writing hello, world, and exclamation, right? And that puts it in the table. Now you can see we do our I pairs, and we're printing those, and then we're end, and then we return the arguments back. So that's not that exciting. It's not a very cool example. But in this case, because there's nothing following the call to this variable arguments function, it's going to return all of those back to print. Since print can take multiple values, it's going to print all of those. For the second one, though, notice this. It's kind of like there's only one slot to put the result of variable arguments. So take a guess at what's going to happen based on how we did this before. When we run this for ourselves, you'll see that the output here looks like we're going to print all the arguments, 1, hello, 2, world, 3, bang, right? So that's the same between each. But notice how in this number 2, we lost the rest of the arguments. That's because we only have one slot, if you want to call it that, to place the value. Okay, so that means we just discarded the rest of the arguments. That's kind of a Lua thing. It's just going to let you discard stuff. That's totally fine. And another thing that we need to talk about for functions is how you can call them. Obviously, you can call them with parentheses. We put the result of take all the arguments that you passed here, put them here. So it's like writing hello, world, and exclamation, right? And that puts it in the table. Now you can see we do our I pairs, and we're printing those, and then we're end, and then we return the arguments back. So that's not that exciting. It's not a very cool example. But in this case, because there's nothing following the call to this variable arguments function, it's going to return all of those back to print. Since print can take multiple values, it's going to print all of those. For the second one, though, notice this. It's kind of like there's only one slot to put the result of variable arguments. So take a guess at what's going to happen based on how we did this before. When we run this for ourselves, you'll see that the output here looks like we're going to print all the arguments, 1, hello, 2, world, 3, bang, right? So that's the same between each. But notice how in this number 2, we lost the rest of the arguments. That's because we only have one slot, if you want to call it that, to place the value. Okay, so that means we just discarded the rest of the arguments. That's kind of a Lua thing. It's just going to let you discard stuff. That's totally fine. And another thing that we need to talk about for functions is how you can call them. Obviously, you can call them with parentheses. We've already done this. The parentheses go here, not like a list where they go beforehand. But if there's only one argument that you're passing and it's a string literal, you can actually drop the parentheses and just go something like this, single string high. And if you run this, you'll see that these two values are exactly the same. No errors. So sometimes you'll see this dropped with the parentheses when there's one string. I don't do it as often for strings, but I do it very often for this scenario, which you can do the same thing for tables. I usually do this most often when I want to sort of emulate like optional or default arguments. Lua doesn't have those. Once again, it doesn't have a policy for how you would define what are optional arguments or default arguments or how you would say it's required, but it doesn't have that idea. Instead, what you can do is sort of emulate this by directly passing a table with no parentheses, and it looks like you're calling it with something like, oh, default is 12 and other is false, right? And in this case, we can check inside of this function, oh, did we pass a default value, right? So if we didn't pass one, it'll be nil. Okay, then we'll set ops.default equals 17, and then we can print these two. Not the most exciting function, but when we do this, sorry for smashing the microphone, you'll see that 12 and false, right? So that's our default, 12 and others false, or, right, for a second option, other is true, we didn't pass default, so we get 17 true. So that's the two other ways that you might see people calling functions, which is definitely surprising the first time that you see these parentheses dropped and it just looks like people are coming up with their own magic stuff. This only works for literal strings and literal tables. Those are the only times.
Literal. That just seems like such a niche. It's like why? Холодно.
Times that works. So we have one other sort of edge scenario to consider for functions, which is when we define a function on a table. So let's say we have some table like this. If we do a dot, right, then we have a list of arguments here. So we can write function, like the table name dot something else, and then these two things are actually equivalent. So this colon sort of magically creates, this is like the only syntax sugar that Lua has, and usually people use this to define like some sort of object system or inheritance or to use something about the table itself. But if you see this colon here, all that does is it's translating this idea into this idea, okay? And really it's just saying, I'm going to call something on my table where the first argument is going to be like inserted as self, and it will be the table that I'm calling. We'll see an example of this shortly in meta table. So if that didn't make
My browser's leaking, dude.
sense, just
I
keep
feel like
that
this
in
should
mind
just be
that this colon
like
is
I would
a
just
syntax
disable
sugar
this.
for dot and self. Okay. All right. So metatables. Metatables are, it's a thing about tables, right? That's the meta and the tables. They describe or change the behavior of tables. This is really similar to like Thunder methods in Python, or like how you would implement different traits maybe in Rust, right? Which is that basically what we can do is we can say, hey, I will give you a table and it will describe what you should do under various scenarios within the language. The first one we'll do, which is the really simplest one, is add. So right down here, we're going to add two tables. Normally that would be bad. You can't just do like Lua table plus table. That's not good, okay? If we just like try and add these, it says, hey, you just tried to perform arithmetic on table values. No, no, no. Don't do that. So instead, we need to define a way for how we could add two tables. And in this case, we sort of have an idea of a vector, like some vector 3, and each of them has 3 values, right? And we're going to tell it, hey, here's what I want you to do when I add these two items, right? So it's like left and right. So this v3 is the result of v1 plus v2. And if we execute this, you'll see that, hey, v3 right here, 1, 2, 3, right? So if we add these two values, these are going to cancel out. That's the 0. Then we have 1 and 2, that's 3. And then 5 and 2, that's 7. And then if we added v3 to itself, that should work just fine too. If we print the whole table, we'll see 0, 6, and 14, right? Which is basically doubling all of these. And Lua knows that this has a meta table with an add function inside of it. That's how it determines that this little plus guy here needs to do something besides the normal thing that it does when you try and add two tables, which is throw an error. There's a bunch of different, these are usually called meta methods because they're things on a table that we can do. The other one that's kind of cool in this scenario that I wanted to go over is called index. So index is called whenever you try to get a value from a table that does not exist. So in this case, we create an empty table and we set its meta table to this Fibonacci meta table we just made. And this key is the value that we're looking for, right? So when I call fib5, this doesn't have fib5, right? It's not around. There's nothing set inside of the table already. So it's going to call this function. It will then check these, and it says the key is not less than 2. Okay, so I'm not going to return. And then what it's going to do is going to update the table, and it's going to call these functions. And funny enough, in this case, we're actually showing how this can be recursively called, right? It's going to look for self key minus 2, and it's going to do the normal Fibonacci thing that I think most of you probably know. But the like cheeky, cute result here is that we're caching these sort of automatically inside of here because we're updating this table. That's what self is. This is like, if we go back a few
That's kind of
pages
cool.
here, where we talked about the colon argument. Where did I already go past it? Was I not paying attention? I already went past it. I wasn't paying attention. Sorry, right here. This self is the table that the method is getting called on, okay? So this self is actually this table. So when we update its value, we're saving or caching these values along the way. So instead of taking forever to calculate fib 1000, we can execute it practically instantly because we're going to save the values along the way, right? You can use a bunch of different options for this. You could like calculate default values that might be expensive, or provide something that always doubles a key. Whatever you want, it's a function. You can write the code. The other two notable meta methods we should talk about are new index. New index actually gets called when we're right here, which is self, key, and then value. So that's sort of like self, key, and value. Those are the things that would get called. So you can actually override what happens when you do new index. You could create like a locked table that just errors inside of new index and you don't allow it. The other one that's kind of cool is call, which
kind of dope.
call a table as a function. So you could like store some state or store some mutable state and call a function on it. You'll see this one used a bit as well. A little less often than index and new index. So some quick NeoVim goodies, because now you actually know basically everything you need to do to get started writing Lua. That's it. That's pretty much the whole language, okay? It's really cool. Here's a few things you can do. I like these key mappings for myself. So you can do vim key map set space xx, and that sources a file. So let's yoink this, and we'll do our same we'll do our same sort of thing that we did last time in the series, which was I had my nvim example here, and I opened up my init Lua. These are not that exciting functions, so we'll keep the print just so we know what's happening here. And if I source this file, what we're going to see now is that we actually have this key map set for us. So if we do no remap space to see what we
He's
have,
using
space
Ghosty
X
these days.
sources the file. So when I press space X, it prints advent of NeoVim. If I had 1, 2, 3 like this, and I go space X, it's going to execute the file and run everything inside of it. Okay, so that's pretty cool. But something that we could do instead as well that I think is really nice is sometimes you want to execute something that's just like the current line. So we could put this in here, and I'll save my file and run space X to execute the file again. Now I have space X to run just the current line. See how this is running whatever is on the current line that I'm doing, just pressing space X here to do that. Unrelated to SpaceX, the company, but obviously if we could get sponsored for just making key maps, do that. That would be super cool. The last one that's really cool that I want to show you is we can do, I'm just going to execute this current line by running space X. Now, if I select some lines and I press space X, it's going to execute just my selection. These are really powerful as we start to build more and more of our NeoVim config. We don't want to completely reset NeoVim every time we want to make a change. We can use this building block of key maps to quickly execute what we're working on and use NeoVim in a live setting. And these ideas are basically how I was doing things along the way to do cool stuff of running this. I just put it into, sort of a special buffer to look cool so that you guys could see this. The last one that I'll do, which I want to show you, is how we can use auto commands and a few of the other things, and how with just the tools that we've learned so far today in this 24-minute video. That's longer than I thought, but that's okay. 24-minute video. We should be able to understand everything that's happening in this chunk of code, right? So let's do that. We'll walk through it, but sort of think ahead of me. Maybe pause even, read through this code, and then we'll work through it together. Okay, so paused. Okay, now we resume. All right, so in this case, we're going to use a Vim. This looks like a table because we got Vim, and then we have .api, so we're accessing the API field in Vim, and then we're going to access the nvim create auto command field in API, right? So we basically have something like if you did Lua equals Vim, you can see it's a really big global with all of the different functions available. This is sort of like the Vim library automatically loaded in. You can do Lua equals Vim.api, and you can see, hey, here's a bunch of different functions. And then we can even do Lua Vim.api.nvim create auto command, and you'll see that that's a function. You say, great, we've got a function. What are we going to do here? Now, if you don't know what this function does inside of NeoVim, you should really try something like this. Auto command, right? Cool, now we can read the help. It says, creates an auto command event handler, defined by callback or command. And then it gives you an example, right? In this case, this basically is like an event listener, if you don't know what this is. So this says, hey, listen to when we yank some text. And what are we going to do? We've got a table now, right? So we see our table, and we say, okay, so our description
do something on yank.
is this string, right? So this is later when we check this, we'll be able to see what the description was. It has a group, right? And we can just read this again and say, oh, okay, we're using Vim's API. We're starting to piece together. Okay, Vim's API is very useful. And Vim create our group, right? And then we're going to do something like kickstart highlight yank this because I yanked this code from kickstart, which I think is pretty cool. And then we're going to clear all the other ones. You might not know exactly what that does, but you could go ahead and check create our group here and say create or get an auto command group or auto command groups. If you remember from last time, we can press or shift K to go inside of here and read about this. I'm not going to read too much about this. You should basically think of this as saying like, hey, I don't want to register this multiple times. Okay, so I'm going to make sure that we clear all the old ones before we make a new one. And then, hey, look at this. We have a callback. We make a first class function, and we call this function Vim highlight on yank. If I execute this file by running space X, and now I yank this line, you'll see I get a little nice, helpful sort of on yank option here that shows me what I've just done. If I do YG, then I've got the whole file. So that's a Lua overview. That's a little bit of goodies from the other. Next time, we're going to start using what we know about Lua now to start building up our whole system and working on that. So I hope you like this video. I hope you like the quick crash course on Lua and the beauty of Vim goodies at the end. Please like and subscribe. Oh, if you made it this far and you really like, sort of my teaching style and other things like this, I'm making a big Lua course on boot.dev. This is the first time that I've mentioned this anywhere. I already have a course on memory management there. So you can check it out with promo code TEEJ, T-E-E-J, at boot.dev for 25% off. And I'm going to work on my Lua course soon. And yeah, that'll come out at some point. Anyways, thanks for watching. Really appreciate it. Hope you like the video. Bye, everybody.
Pretty solid vid. Dude, my browser's clapped. Oh my god. Holy guap. I don't even know how to manage this. Whatever. Okay, browser's useless. I'm restarting the browser. It's just GG. Actually, GG. Opens the same problem tabs. Ladma. So, get a little tab mix up here. Let's go here. The auto moving forward is very annoying. Okay, so what was I doing there? What's the state? Test. I'm in the completing wrong directory. So all the tests pass. What's the state of the application? Okay, so it's living a long time. It's moving. It's doing stuff. Okay. So I believe I was trying to debug why it's not loading very well. So if we just do o.main, it's cached. So if I go to cd, actually here, where is anonymous pet? Gonna remove the cache again. So at least it's saving the cache, it appears. Tamagotchi. So now if I quit, okay. Still resetting. Birth time. Hmm. So it's still resetting the birth time. So let's go back to the window and see how we're displaying the birth time. Get age /1000. Yeah, it would be kind of annoying passing self in here. Yeah, that makes sense. Get age. Hello? Is anybody home? Hey, get age. Self.birth time. Self. Let's freaking go. Отлично. Ooh. Very well. Very well. Let's go. Everything got updated. YouTube got updated, Instagram updated, and GitHub got updated. 83 views from one unique visitor is crazy. Crazy is crazy. 22 unique cloners doesn't make sense to me. Oh, it's the freaking CI. Oh god. I actually really like GitHub. Even though it's gotten Microsoftized and it will probably only get worse over time. So it currently does nothing. So none of the real functions should be documented in this way. Really, just the config. I mean, so approaching time to quit streaming. Casual 2 hours stream. Anything else I want to do? Could update the website to talk about tamagotchi.nvim. Tamagotchi.nvim. Algorithm of creating FPGAs in Pascal. Academic curl. The green language. Avoiding libraries. And studying Russian. You also make sure the books list is accurate. Getting through 3 easy pieces. Blah, 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 blah. Blah, 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 blah. The activity overview is kind of trash. I don't like it. It's just like commits. Yes, I tend to do commits. Can I just leave this? I think I'm just dipping out of this ugly. Do I need to promote someone to leader? Everybody's an owner. Alright, I'm just dipping out of this. How do I leave? You just remove yourself, I guess? Casually remove yourself. Type. My process for design project, I thought it was hard, but we just weren't supposed to do it yet because they didn't teach us anything. I thought they weren't going to teach us anything, but they're going to. All right, I think I'm in it there. Solid work. In there.